on compound inequalities and how to solve them. I did promise that I would create a video, and here it is. So the first type of compound inequality we're going to go over in this video is the AND problems. We call them an AND problem because it either literally says the word AND in it, or you can see that they're combined into one piece. So for this first example, we have 8x plus 8 is greater than or equal to negative 64, and, like it literally has the word and in the problem, and negative 7 minus 8x is greater than or equal to 79, negative 79. So to begin with, we don't do anything different than we would solving any, multi-step or two-step inequality. We isolate the variable. We're going to follow that same process. So subtract 8. 8's cancel. 8x is greater than or equal to negative 72. And once again, trying to get x along, we'll divide both sides by 8. And x is greater than or equal to negative 9. Make sure you keep the sign going the same way. Since we did not multiply or divide by a negative number, we're not going to flip the sign here. So this is all a part of scratch work. This is the first portion, we think, of the solution. Going over to the other side, still want to isolate the variable. So we're going to go through during our reverse order of operations. 7's cancel, we get negative 8x is greater than or equal to negative 72. And this time we're going to divide by a negative 8. So we will be changing the direction of the sign this time. X is less than or equal to positive 9. Okay, so now that we've solved them both independently, we have here, we think the answer is x is greater than or equal to negative 9. And, like you're bringing down that word, and x is less than or equal to 9. So we're going to look at the graphs to actually see what the final solution will be. I always like to draw 3 graphs, one for the first portion of the answer, one for the second portion, and then the third one will be where I put my final answer based on what I see on the first two. So I know I had a negative 9 and a 9. I kind of cheat a little bit, and I only write the important numbers on my number lines for my scratch work. And I am doing this scratch work in Jamboard. So I will be sharing the link to this board where you can actually go in and look at all of this scratch work. So x is greater than or equal to negative 9. That means I need a circle on negative 9 that's shaded in. Okay, remember this one was x is greater than or equal to negative 9. Okay. So here we know that the inequality is open to the x, which means that's larger. So we're shading for numbers that are larger than negative 9. We would be shading this way. Okay, now we move on to the next part. We have x is less than or equal to positive 9. I'm going to draw that on my second number line. Circle on positive 9, closed in, right? Because remember our inequality was x is less than or equal to positive 9. Here our inequality is open to the 9, which means 9 is bigger, and these possible values of x are smaller. So we're going to shade smaller, which would be back here. And when we finalize this problem for an AND problem, we take what they have in common. So I can split it off here and here. And this is the portion that they share. So that's going to be my final answer. We're going to go from -9 included to +9 included. That is our solution. So x is between -9 and 9. That's one way we can write an answer all in one piece. Okay, the other option is to write the answers in two pieces with the word and between, just like we had when we did the scratch work. Okay, I do suggest you do your graphs first before you just declare your scratch work as the answer. Do your graphs so that you can see the numbers here. In our next example, we are taking a look at another AND problem, but this time, as you can see, it's written in one piece, similar to how our answer was written the time before. So it is a little bit different, but I like to think that these are easier to do actually than what we had before, a little less work. So what we have is two inequalities completely joined together to form one piece. And everywhere we have an inequality sign is actually a separation of the problem. So there are three areas. We have this area, the one in the middle, and over here. Your goal when you solve this is to isolate the variable in the middle. You want the variable to be there between the two inequality signs alone. So you want it to end up looking like this one when we got finished here. So we want to go through the same process to solve. We want to get P alone. We'll be moving the 6 first. The only difference is you're adding 6 in all three areas versus just adding 6 on one side. So it's in 3 places. The 6's cancel. We're left with 3P in the middle. Over here, -30, and here, -9. And then you keep going. You got to get rid of the 3, so you would be dividing in all 3 areas. 3's cancel, you get a P. Now, we divided by a +3, so we're not changing our sign. If we had divided by -3, then we would be changing the direction of our inequality signs. So -30 divided by 3 is -10, and -9 divided by 3 is -3. So this is our solution, and we can graph it on our number line. And I put in the numbers that matter, right? Open circles because it doesn't say or equal to, and you simply shade in the middle. So that is another type of AND problem. Mommy. For our last example, we have an OR problem. It says OR in it, and every time you have an OR problem, it's going to say the word OR, okay? So just like we started off on the first problem, we're going to solve each one of these inequalities separately. So isolating the variable, first thing we want to do is add 1 to both sides. We know the 1s are going to cancel. That leaves us with -10a is less than 0. Dividing both sides by -10, and you know, when you divide by a negative, you have to switch the direction of that sign. So we have a is now greater than 0 divided by -10, which is still 0. Moving on to the other side, still isolating the variable, subtract -10 from both sides. We end up with 3a is less than or equal to -15. Divide both sides by 3. And a is still less than or equal to, we don't need to flip the sign, less than or equal to -15. And remember, this was a OR problem. So scratch work is still gonna still going to kind of be the same. When I flip over to the next screen, I still want to do 3 number lines, one for the first possible answer, one for the second one, and then the last one will be where I combine and put my final answer. So I have A is greater than 0 for this one, and A is less than or equal to -5 on this one. So putting my 2 numbers that I need, but actually let me put them in the order they would come numerically. So -5 would come before 0. -5 and 0. One more time. So I need an open circle on 0, and it says A is greater. It's open to the A, so greater is shaded this way to the right. For the second part, we're going to circle -5, circle it in, darken it in because it has or equal to. And you can see it's open to the -5, which means A are numbers less than, so we're going to shade this way. Now, since this is a OR problem, instead of doing the overlap like we did before, this time we actually take all possible solutions and make sure they're both shown. Once again, for an OR problem, you take all the possibilities, the possibility from option 1, the possibility from option 2, and they both, everything has to go on the final answer graph. So we're circling in -5, shading this way, and open circle on 0, shading this way. And that is your final answer as a graph. To write your answer out numerically, you just take what you got when you finish your scratch work. A is less than 0, or A is less than or equal to -5. Okay, so you have your answer algebraically as well as graphically. And that's going to complete our lesson on compound inequalities.